We're going to finish up today. We're going to talk about two topics: the Big Bang and radiocarbon dating. Both of which, a lot of times, preachers and common Christians will stay away from because they fear that maybe there's something out there that they don't know, and so therefore they're not going to talk about it. I would point out of all the people I've ever met, probably only maybe 0.2 to 0.5% really understand the Big Bang to begin with. So when you speak on it, realize there's not that many astronomers out there in the world. There are some people who read articles on the web and think they know everything. But the reality of it is most people are just as clueless about the Big Bang as you are. Same thing with radiometric dating. So here's my advice to you. Don't get bogged down in all the minutia because there's a whole lot of little bitty details that people can drag you out on. Make them basically look at the big picture, the generalities, because when you look at the big picture for things like the Big Bang, it's miserable science. I divide this up into two phases, and I want you guys to be able to defend both. I think obviously one is more important than the other, but we need, as Christians, we need to be able to ask the question, okay, is the Big Bang scientific? That's question one. More importantly, can we fit it into the Bible? Is there a way we can squeeze the Big Bang theory into God's Word? I am going to kick off this PowerPoint. Hey, Dean?
Yes.
Why don't you tell everybody there how ugly you really are?
Oh, wow. I mean, if I was any uglier, I'd look like Brad Harrub. So,
okay, there you go. That's good. I just needed you to talk it long enough to kick it over. All right.
Okay.
Yeah. Here we go. Could God have used the Big Bang? If you were to take a poll among young people, and I've done this at summer camps, and I would encourage you guys to think about doing this on occasion when you go to a congregation. Hand out a little survey to your maybe 5th through 10th or 11th graders. Just ask them things like, where did the universe come from? When did dinosaurs roam the earth? Where did man come from? You will be shocked at how many have already been indoctrinated by the Big Bang Theory. Because in one of the camps that I did, over 50% of them believed that we came from a Big Bang explosion. Let's start out by talking about scientific problems with the Big Bang. Now, we touched on this a little bit already. Some of this will be a little bit of review, but I think it's worth it. First thing, textbooks do not explain where the original matter for the universe came from. So what the textbooks actually do is they start with a picture like this that starts literally mid-bang. So if you look at that picture closely, you go all the way over to the left where it talks about quantum fluctuations. The question is, where did the stuff for those quantum fluctuations come from? Where did the original matter come from? Because they basically start mid-bang. Somebody look at that picture and tell me the two problems with that, scientifically speaking.
It's all heading in the same direction.
Okay, but realistically, we'd say this is three-dimensional.
Okay.
What does it violate?
The law of, as well the inertia. Which one is that?
First and second laws of thermodynamics. First law of thermodynamics says you can never create matter. Well, guys, it doesn't take a rocket scientist to figure out if you go from this small little point in space to having suns and stars and galaxies and Earths and planets and things, you've created matter. The second law of thermodynamics says that everything is always moving towards a a more chaotic or more disorganized state, more disorder. Things run down, things wear out. Well, when you look at this picture, you realize you've got an explosion that is now going to result in a very organized universe. So right off the bat, you are violating two very fundamental laws of thermodynamics. Now, their answer to that is going to be, well, that's in a closed system. My answer would be, okay, the universe is pretty much a closed system if you think about it, folks. It doesn't get much more closed. There's not anything outside of the universe that's acting on it. So, let's look at how they explain where it came from. This is a good quote from Paul Davies. He said, "The Big Bang represents the instantaneous suspension of physical laws, the sudden abrupt flash of lawlessness that allowed something to come out of nothing. It represents a true miracle." Now, my point would be, why in the world is that more scientific than saying in the beginning God created the heavens and the earth?
Exactly.
Point number two. This Big Bang allegedly happened 18 to 20 billion years ago. So now we bring some science into the picture and we say, all right, we got a problem because Jupiter is too hot. John and I talked about this last Thursday. Jupiter is cooling off. It's losing twice as much heat as it receives from the sun. Guys, if this Big Bang happened 18 to 20 billion years ago, it would have long cooled off by now. And you say, well, Brad, how do you know that? Just by displacement alone, a planet as big as Jupiter, I mean, you think about this. If you've got a brownie that you burned in the oven, you set it out, and you go and you record how long it takes to cool down, eventually that brownie is going to reach room temperature because the energy in the brownie is going to be transferred to the room. Same thing with Jupiter. And yet, NASA has photographed volcanic eruptions. We talked last week about Ganymede having a strong magnetic field, and that anytime you've got a magnetic field, that means that there's liquid molten metal inside, and yet it should have long cooled off a long time ago. Next one is the law of conservation of angular momentum. Scientific law. To our knowledge, it has never been violated. Basically, it says this: if you've got a central axis where all the energy is coming from, everything in that should be moving in the same direction. I'll show you an easy picture of it. Here's a spiral galaxy. You'll notice everything is rotating in the same direction. That's what we would expect if everything came from a single Big Bang explosion. The easiest way to think about it is if you put 3 kids on a merry-go-round, you spin them as fast as you can. Eventually, they're going to come flying off that merry-go-round. But they're going to be moving out in the same direction. And yet, guys, if you consider the center point of that merry-go-round, the Big Bang explosion, where everything happened from, we would expect all of the matter in the universe to be moving out in the same direction, and yet we know it's not. We know, for instance, that Venus, Uranus, possibly Pluto are rotating backwards from the other planets. We know that 6 out of the 63 moons here in our own solar system are rotating backwards. Jupiter, Saturn, Neptune, they've got moons going in both directions. The point being, you are not going to get this from some Big Bang explosion. What about the very essence of the universe, the way that it looks? If there was a central Big Bang explosion, we would expect all the matter in the universe to be very evenly distributed. And yet we know that there are areas where there are lumpy clusters of galaxy. Then we know there's areas where there's just nothing but voids in space. Something that would not be predicted if the Big Bang were true. To me, though, this is probably the biggest problem right here. Big Bang Theory relies on 96% of material that we've never seen or measured. And by that I mean this, guys. The universe is expanding in such a way that astronomers can't figure out what is holding it all together. What keeps a planet from literally zipping out into space, never to return? What's holding everything in? So they come up with two things, dark energy and cold dark matter. And according to their theory, 96% of the universe is created with these materials, neither one of which we know for sure actually exist. So again, to me, it takes a whole lot more faith to be an atheist, to be an evolutionist, than it does to be a Christian. I've showed you guys this quote before. I will refresh your memory. This is from an astronomer, Bob Berman. This was actually penned in the journal Astronomy in July 2004, where he gives a warning that he says should be given to all, in front of all articles that have to do with the Big Bang. Listen to what he says. Suddenly we're embedded in a frothy quantum foam of unlimited possibilities. It is a free-for-all where each solemnly presented theory is soon changed or rebutted. In one sense, it's very cool. Imagination rules. It's a unique period in cosmology's history. Throw the math this way, that way, tweak the equations, set fire to the physics building. Nothing matters. It's like Alice in Wonderland meets Stephen Hawking. Unfortunately, he goes on to say, cosmologists are starting to resemble naked emperors parading before the mass media. Hey, we love you, but you have no clue about the universe's true origin or fate, and little knowledge of its composition. Yet each pronouncement is delivered with pomp and flair. Maybe you need a serious timeout, he said. He then suggests this warning be placed before any cosmological articles. It says, warning, the following contains contemporary cosmology. Reading it can produce disorientation and confusion. Nobody knows what's going on here, and nothing you read here is likely to be true.
Did you publish that, Brad?
July 2004, the Journal of Astronomy. Now, let's talk for just a second. Tell me why, biblically, Christians cannot buy into the Big Bang Theory. What's the problem? Dean?
Well, for starters, it eliminates the creator. Just the concept of the Big Bang says that something just happened and exploded into order, and it doesn't identify.
Okay, but what about the person that says, maybe he used a Big Bang? I mean, in the South, we have bumper stickers that say, yeah, I believe in the Big Bang, God spoke and bang, it happened. So, how as a Christian should I view the Big Bang? Chuck?
Well, we have to understand some terminology. The Jews nor the Greeks had a word for universe, so they explained everything as the heavens and the earth. So in Genesis 1:1 it says God created the heavens and the earth, and to them that is the universe. So he didn't create this 25-pound thing of matter. He created the heavens and the earth, and we can read that it was made full.
Okay. Very true.
On day one, the heavens and the earth were made. It wasn't until day 4 that the sun and the stars and the moons were made. So, I mean, there's a difference there. They weren't at the same time. The Big Bang says everything happened at the same time, and everything is a result of that. But, you know, Genesis chapter 1 says there's a difference there. It wasn't at the same time.
Okay, Jerry, when you're teaching your kids, what do you tell them as far as when the stars and the moons were created?
Well, that was day 4.
Oh, did I?
Day 4.
Oh, okay.
Yeah.
Day 4.
Yeah, I teach.
So how do you go ahead.
No.
Go ahead.
Well, as far as the Big Bang, I think the reason a Christian I can't accept it because it just represents compromise. Why not just say in the beginning God? Why we got to go Big Bang? All of a sudden. So it just represents a compromise to me, and I think it's a lot of people in the church Brad, they're saying, well, this is the only thing that's separating us is this creation issue, and it's like, hey, well, we can't change it just because we can't agree. We got to kind of stick with what the Bible says or not. So that's my problem.
But the point is, it is an issue, and it's a
Absolutely.
pretty big issue.
No, it's huge. Yeah, I agree.
Yeah. John?
If you cannot take God's creation literally as a 24-hour period, 6-day, 24-hour period, then you can't take anything else literally in the Bible, presumably. I mean, anything else
Absolutely.
goes. That's the base.
Guys, that's the point, is our kids are watching as we tell them, hey, you've got to be baptized, you've got to be in the one true church, and then they watch us compromise the opening accounts of God's Word. And they're sitting there going, okay, you're wanting me to pay attention to this over here, but you're not paying attention to this over here. So, what gives? James?
I was just going to say kind of what Jerry was hitting on, where this is just another way of people trying to explain everything in the Bible in a very naturalistic way, whether it's prophecies of Isaiah or
Absolutely.
the unity of the Pentateuch, or how even the Red Sea was parted. Everyone tries to come up with a naturalistic way of explaining it, and this is the same thing.
So unnatural.
Absolutely. Guys, one of the areas that where you're going to have to brush up on, and, had I been working at Bear Valley longer and had been physically there at the campus and could bend Denny's ear occasionally, one of the things that I would talk to him about is we've got to make sure these guys can defend things like miracles and defend the supernatural aspects of the Bible, because James hit it on the head. There are a lot of people who are basically trying their very best to explain everything away with naturalistic events, and those that they can't, they either ignore or they kind of chalk them off as, hey, that's poetic language, or that's just a story, or blah, 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 blah. It's like we love accounts like Daniel and the Lion's Den when we're a kid, but then when we reach the scholar level, we don't like them anymore because all of a sudden we can't use naturalistic means to account for it. When the fact is, there are no naturalistic means. That's the whole point, is that proves God. And we need to remind ourselves of that. Other comments, thoughts? This is a quote from George Greenstein. He said, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency, must be involved. Is it possible that suddenly, without intending to, we've stumbled upon scientific proof of the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit? Kind of a telling quote from a guy who would normally not admit that there is a God. This is an article that came out August 2002 in the journal Nature. Those of you who know anything about science, there are two science journals that are the big guns. One is Science, the other is Nature. So you got a quote from the Premier magazine. Listen to what they say. Our universe is so unlikely that we must be missing something. In an argument that would have gratified the ancient Greeks, physicists have claimed that the prevailing theoretical view of the universe is logically flawed. Arranging the cosmos as we think it is arranged, says a team, would have required a miracle. The point is, absolutely it required a miracle. They are basically making the argument for us. They go on to say, the incomprehensibility of our situation even drives Dr. Susskind's team to ponder whether an unknown agent intervened in the evolution of the universe for reasons of its own. Translation, we're kind of wondering if maybe there's not a God playing in all of this. We're not going to call him God, and we're going to keep using evolutionary terms, but man, something doesn't jive here. We talked a little bit about, okay, can a Christian buy into the Big Bang? You guys know that I'll use the argument about water being on the earth, because on day one, the Spirit of God was hovering over the face of the waters. We know day 4, finally we get the sun, the moon, the stars. Well, guys, the Big Bang would testify that all of these other heavenly bodies were around long before the earth. And you can't get water from some very, very hot Big Bang explosion. At which point, then your nice, kind, sweet little Christian is going to say, well, then maybe each one of those days wasn't really a day. And that's where you guys are going to have to be well-versed and teach them what the text says and why we can know that each day was a day. Okay. Any questions, thoughts on Big Bang? All right. What is radiocarbon dating and how does it work? Let me back up for just a minute and do this. Guys, there are roughly 23, 24 ways in which you can date the Earth. In fact, there's a website I could probably put you on that shows all the different types of ways that you can date things. Of all those ways, only 3 give you very, very ancient Earths. The rest of them give you relatively young Earths. Now, guess which 3 the media and scientists continually lean to? It would be the 3 that are giving very ancient ages. These are things like radiocarbon or radiometric dating. So one of the last things I want us to touch on before we look at starlight and time is, okay, how can somebody explain the whole radiometric dating, and what do I as a Christian need to know about it? The slide that you see on the screen, hopefully right now, there you go, is a simple explanation of how radiocarbon dating works. Long story short, and I'm breaking this down for you as easy as I know how. Long story short, the radioactive form of carbon gets ingested into plants and animals because of it comes through the atmosphere. Radioactive carbon is in plants and animals, and when that animal dies, it begins to decay. The way that we measure things is we look at how much of the decay of that radioactive material is gone. So, for instance, let's see. Here we go. Let's say we find a bone, we want to know how old it is. First thing you do is you measure how many radioactive units. I'm going to use different numbers than what you see on the screen just so you can follow me. Let's say that we find a bone buried in Dean's backyard. It's got 10 radioactive units in it. We then compare that number to what you know animals have today. So let's say we find a human femur. We start wondering if Dean is sane. We realize it's exam week. And we measure it and we realize, okay, it's got 10 radioactive units. We measure a femur from a living modern human. That's got 20. So femur's got 10, we've got 20. We know, therefore, that means basically you've got a difference of 10. The half-life of carbon-14 is 5,730 years, we think, meaning every 5,730 years, we lose half of the radiometric carbon that's in our body. So let me take the screen away for just a minute so I can explain this by looking at you. So if Chuck died right now, all the radioactive carbon that he has eaten through plants and animals, it would start to decay. And according to their formula, he is going to lose half of that radioactive material in 5,730 years. Does that make sense? That is the half-life of this radioactive element. Now, if we find a bone out back at Dean's house that's got 10, we've got 20, we can assume it's lost half of it. So how old should that bone be? 5,730 years. Couple of problems with that, guys. Problem number one. How many people have lived 5,730 years? To know that's the true half-life of carbon. Nobody has. Second problem is this dating method, and please, I don't expect you to memorize every one of these points, but I do expect you to at least kind of be familiar with them. On the screen, you're going to see a list of 7 assumptions. Guys, all 7 of those have to be correct in order for this dating method to work.
We can't read that, bro.
Then I will post that up on my iDisk. How about that?
Page 298. 298. Yeah.
There you go, John. That's what I'm talking about. That's a man who's been reading his book right there is what I'm talking about.
You quoted Josephus, so I just figured the rest of the book was bad, right?
Ouch.
That's exactly what you did.
I think you just used that one bullet.
Mr. Coker,
Yes, sir.
you and I have a date with Destiny on Thursday, brother.
I'm reading your book.
Let me give you guys a very easy to remember, easy to understand example of why this is no good. Okay? Let's say that this preaching student class was suddenly covered over with dirt and fossilized. And the same thing happened to a group of preaching students up by Mount St. Helens. They come back 1,000 years, they dig you up. Now you're living as contemporaries, so you should date the same. Your bones should date exactly the same age. They're actually going to date younger than you guys because they've been eating plants and animals that were exposed to more radioactive material when that volcano went off. You got Mount St. Helens erupting, putting more radioactive carbon in the plants and the animals in that area. Likewise, the people ingest that. They therefore have more radioactive carbon. They're going to date younger than we would, even though we're living at exactly the same time. So one of the very first assumptions that we need to understand is wrong is uniformity. Radiocarbon dating depends on uniformity. It cannot account for volcanoes, hurricanes. It can't account for what's going on in Haiti right now. All of that gets thrown out the window. I'm going to read these assumptions, or a couple of them. Number 2, has the half-life of carbon-14 been accurately determined? Number 3, has the decay of carbon-14 varied in rate? Meaning, is it possible that it can actually vary, where it decays quicker at the beginning or slower at the beginning? Number 4, has there been contamination with the sample? How do you know over in California where they have wildfires every other year that that's not affecting the radiometric carbon? Yes.
Would a fossil fuel, like oil or something, be a contaminant, considered a contaminant?
Any kind of, absolutely, yes. Anything that can get into that original sample and add or take away carbon-14 would absolutely be a problem. Then the last point that I make there is on instrumentation. Are you 100% sure that the instrumentation is precise, that it's always going to give the same results? And guys, I've worked in labs enough to know that's a huge problem. A lot of the science that is being done today is being done by undergrad and graduate students who realistically, in the grand scheme of things, they're not as concerned about how well they do the study as they are, do I get the results that my professor wants? And so are there contaminants? Are there issues? Was the machine calibrated properly? All of these things have to be considered. On the screen right now, I'm showing you some published errors. And again, I think these are in the book. Let me make sure.
$2.99.
There you go. Living mollusk was tested at carbon-14 dated 3,000 years old. Key word there being a living mollusk. Freshly killed seals dated at 1,300 years. Mummified seals that were dead only 30 years have given ages as high as 4,600. Muscle tissue from a mummified ox gave a date of 24,000 years. Hair from the hind limb of that same animal was only dated at 7,200 years old. Wood from actively growing trees given a carbon-14 date of 10,000 years old. Mortar from an Oxford castle in England dated at 7,370 years, and yet the castle was built only 785 years previously. In fact, to me, this is probably one of the biggest ammunitions there is. This is a quote from Richard Dawkins. It is not out of context. Do what? Go ahead. Anyway, it is not out of context. I grabbed the whole thing just so that you guys could see what he's talking about. He said different kinds of radioactive decay-based geological stopwatches run at different rates. The radiocarbon stopwatches buzz around at a great rate, so fast that after some 1,000 years, its spring is almost wound down. The watch is no longer reliable. It is useful for dating organic material on an archaeological or historical time scale where we're dealing in hundreds or a few thousand years, but it is no good for evolutionary time scale where we're dealing in millions of years. So even the staunchest atheist is saying, look, this thing is no good. You get outside of a couple thousand years, it's no good at all. So do I put a whole lot of stock in radiocarbon dating? Absolutely not.
Not with Richard Dawkins doesn't.
Exactly. And, you know, that's a pretty good comeback. When somebody says something about it, simply say, well, you know, I just hold the same position that your king or your whoever your Oompa holds, Richard Dawkins. All right, last topic that we are going to discuss in this class is starlight and time. Somebody tell me why this is a topic we need to even discuss in the first place.
Don't they say that light travels at in order for light to get to Earth, it has to travel millions of years to get here, something like that?
Okay,
I just
absolutely.
remember what was used at the debate the other day. You just kind of cheap shot at Chuck.
Jerry, have you ever heard people who need this much cheese to go along with their wine?
I'm just spitting out facts.
All right, Chuck, why do we even need to discuss this?
So I can debate you again. Well, if it's younger, then we still don't have enough time, according to these evolutionary scientists, for light to have traveled here yet.
Okay. So here is the argument. You've got a star a gazillion light years away, and we're able to see the light from it today. They would say that the light had to leave that star a gazillion light years in the past in order to reach us here today. Therefore, that proves that things are old. In the book, I show you a couple of things. Number one, how we measure starlight. And then I give you about, 6 reasons why starlight and time is not a problem for us. The first point we need to get off the books very quickly, and that is, do we know for sure God created a mature creation?
Yes.
Absolutely. Do not forget that, guys. We know that when Adam and Eve looked up into the heavens, they were able to already see what? Starlight. Okay, in fact, Mr. Coker, read for me Genesis 15, verse 5. Chuck, be pulling up Jeremiah 33:22.
And he took him outside and said, "Look toward the heavens and count the stars, if you are able to count them, or if you are able to count them." And he said to him, "So shall your descendants be."
Okay,
As the host
so
of
we
heaven,
got. Go ahead. Go ahead.
as the host of heaven cannot be counted, and the sand of the sea cannot be measured, so I will multiply the descendants of David, my servant, and the Levites who minister to me.
Okay, so I think everybody would agree that the people in Genesis could see starlight, or that Jeremiah, Abraham, that these people could see stars. That being the case, we need to be able to explain how they could already see starlight. The first answer is God created a mature universe. But, having said that, that's not a good enough answer, guys. And here's why. There have been cases where we've actually seen stars form or fade out. So if we see a star form or fade out, suddenly that's a whole new dimension. That's kind of a whole another ball of wax that we can't just paint a broad brush and say, mature universe, everything's cool. So I put in here 5 other things for folks to think about. The second one is the universe is expanding. It's a known fact, which would mean any star that we're looking at used to be closer to us, which means the light did not have to travel as far. Number 3 to me is, let's see. Number 3 is also a decent argument. Scientific fact that gravity plays a role on time could also play a role on the speed of light. We know clocks on the top of a skyscraper or mountain run faster than those at sea level. I don't know how many of you guys knew that you can actually stand at the bottom of the Empire State Building, have somebody standing at the top with identical watches. The one at the bottom is actually going to run faster than, or it's going to run slower than the one at the top because of the effects of gravity. So outside of our gravitational field, the speed of light may actually change. Number 4, though, is the one that you need to memorize and keep in mind, because when this argument comes up, you're going to kick yourself in the shin and say, oh, man, what was that Brad told me to memorize and that I should have put in my notes, and now I can look back because I got this 15-year-old child in front of me wanting to know what the answer is. The answer is, guys, we know the speed of light is not a constant. It used to be a constant. And in fact, on this earth, it is still a constant. But we now know outside of our gravitational field that it's not only faster, we think it could be exponentially faster. Meaning once light actually gets out into space without anything to inhibit it, whether it be gravitation or our atmosphere, it not only is fast, but it speeds up as it goes through time. Number 5, in addition to the speed of light variable, it is unknown as to whether light has traveled at the same speed throughout history. In other words, did light travel at the same speed pre-flood?
Not on the earth, right?
Do what now?
Oh, you mean outside of the earth?
Yes.
You mean, I don't know.
John? Yeah.
Go ahead, Joe.
Either one of you. Go ahead.
I think the firmament or the expanse could have had some kind of bearing on that.
Absolutely. If you've got a canopy out there, is that going to affect it? Absolutely it will. So I guess the bottom line, guys, that you need to remember is this. Number one, you've got a mature creation, mature universe. Number two, we know the speed of light is not a constant outside of our atmosphere. There are other factors, there are 4 other factors that could come into play. Expanding universe, gravitational pull, variable speed of light, etc. But the point being, as a creationist, do I have a problem with starlight and time? And the answer is no, absolutely not. Questions, comments, or thoughts? Okay, what we're going to do last is we're going to watch a movie called Expelled.
Yes.
And I will ask Mr. Wayne if he will shut the recording down.